This is Scorpion, the only robotic solution you need for any crisis situation. With a long heritage, based on the highly successful Tiny 4WD platform from Cortec Robotics, Scorpion is the obvious choice for any agency seeking the best. Scorpion has 4 individually controlled motors, with high-precision encoder feedback. The mechanism wheels enable the platform to move in any direction, while facing any direction, for ultimate agility and positioning flexibility. The machine can be fitted with an advanced 3 degree of freedom manipulator arm, with a choice of end effector suited for the situation at hand. Here, the grabber is used to effectively and autonomously deal with toxic waste. The Scorpion system comes with remote sensing and low latency video transmission as standard, providing access to areas too hazardous or inaccessible for a human operator. Coordinated motion control between the chassis and the manipulator enables precise inspection of objects of interest. Our state-of-the-art, scratch-built, computer vision system allows Scorpion to identify its goals and make sense of its environment. Scorpion can also be fitted with a highly accurate, laser-targeted cannon. Depending on the requirements of the situation, it can fire less lethal, ordnance disposal, or biohazard containment rounds. Multiple Scorpion units can be configured to work cooperatively in the same area of operation. Great for redundancy, or quick crisis resolution. If you're looking for the absolute best in disaster zone robotic assistance, choose Scorpion and contact our sales team now.
We're Team Brian², and you just saw a demonstration of our robot Scorpion. We're both Cambridge-based makers, PyWars veterans, and members of Cambridge Makespace, which is where we met. Oh, and we're both called Brian. This year we decided to team up for the first time, with Brian Corteil on the right focusing on our robot hardware, and myself, Brian Starkey, on the left, focusing on the software. The chassis is based on the Tiny 4WD design which Brian C. made for Magpie magazine all the way back in 2016. Since then, various Tiny-based robots have been entered in PyWars, but never by the original creator. We're fixing that this year, though admittedly we've made a few enhancements to the design. The main electronics are a 02W as the main controller, a PyCamera V2, 4 motors and quad motor driver, distance and orientation sensors, serial servos for the attachments, lithium-ion batteries for power, and a custom PCB to hold it all together. Here you can see the different interfaces of the custom PCB and how it sits installed in the base of the robot. Everything connects via the PCB, with the exception of the USB for the serial servo driver. The main attachment is a 3D printed robot arm with 3 servo-driven joints. The overall shape is what gives the robot the name Scorpion. We can swap the end of the arm between a grabber for picking up barrels and a camera holder for getting a better vantage point in Minesweeper and Lava Palava. The second attachment is a ridiculous servo-controlled Nerf gun using an aluminium worker mod. It's called Banshee because it screams. The code is written in Python and consists of many processes to overcome Python's multi-threading limitations. The service processes all communicate with the main process via Python queues. The motor 2040 is running MicroPython, providing PID speed control for each motor. There's also a telemetry web page streaming video and sensor readings via WebRTC. The overall stack keeps all 4 cores of the Pi around 60% utilization when running autonomous challenges with telemetry streaming. All camera processing is done from scratch in Python with the assistance of NumPy for speed. There's 2 basic operations. First, pick out the relevant colored pixels from the input image, and second, identify groups of the same color providing their size and location. We're processing images around 80 by 60 pixels, generally faster than 30 frames per second. We're hoping to compete in the following challenges autonomously. Lava Palava, using the camera to find the line and IMU to detect the bump. Eco Disaster, using the camera, distance sensor and IMU together to guide the whole challenge. Escape Route, using the distance sensor and IMU to detect the walls and keep a steady heading through the course. And Minesweeper, using the camera and IMU to find and approach mines. We will attempt the other challenges by remote control.